Introduction to differential equations. Differential equation is an equation that relates one or more functions and their derivative. If the function is using notation f of x, the derivative is going to be f prime. So f and f prime will be in the same equation. The initial value problem, or the IVP, is the differential equation, the f prime of x and the function in x with the initial condition provided as f of a equals b. A and b are real numbers. The solution of the differential equation will be in the form of the f of x. And this function solution satisfies the differential equation and also the initial condition provided. Examples: find the solution of the following initial value problem. The solution of initial value problem, the first part here is called differential equation, and f at 1 equals 24 is called initial condition. So we're going to find the solution or find the function f of x that satisfies both differential equation and the initial condition. As f prime is 7x to the 6 minus 4 x to the third plus 12. To find the function f, the function f is the antiderivative of the f prime with respect to x, which is the antiderivative of 7x to the 6 minus 4 times x to the third plus 12 with respect to x. So we're going to find the antiderivative term by term. The first one, the constant multiple, which is 7, the power 6, which is not negative 1, so use the power rule. So x to the power 6 plus 1 divided by 6 plus 1. The second term, the constant multiple, is negative 4. The power is 3, which is not negative 1. Again, we use the power rule. So then the new power of the x is 3 plus 1 divided by 3 plus 1 plus the last term, which is 12, or the same as 12 times x to the power 0. Then we get 12 times x to the 0 plus 1 divided by 0 plus 1, and then plus c as a family of the antiderivative. Now we have f of x equals 7 divided by 7, which is 1, multiplied by x to the power 7, minus 4 and 4 reduced to be negative 1 times x to the 4th, plus 12 times x plus c. And this one, since we call the all antiderivative, we also call this as the general solution because it has the constant c added as the arbitrary constant. So the solution must satisfy the initial condition. As the initial condition, the IC or initial condition for x equals 1, y, which is the f at 1, equals 24. So we're going to replace it into the general solution that we just obtained to get 24 equals 1 to the power 7 minus 1 to the 4th plus 12 times 1 plus c. Then we get 24 equals 12 plus c, or c equals the value 12. After we get the value c equals 12, now we can put them together as the solution that we are looking for. So the answer or the solution is f of x equals x to the 7 minus x to the 4th plus 12x plus 12. Example 2, f double prime at t equals cosine t, and this part is called differential equation. It is the equation or the equal sign involving the function and the derivative, which is the second derivative for this problem. F prime at 0 equals 3, f at pi equals 4. These two, they are called conditions. Now, our goal is to find f at t that satisfy differential equation and these two conditions. To find the f, that means we have to get away the two derivatives here. So we have to do antiderivative twice. First, we're going to find f prime at t. The f prime at t is the antiderivative of the second derivative, which is the antiderivative of the cosine t with respect to t. The function that its derivative is cosine is sine function. Or you can check the derivative with respect to t of sine function is cosine function. So that's why the antiderivative of cosine t is sine t. And we add the constant of integration, which is called the arbitrary constant. We're going to use the c subscript 1, which is from the first antiderivative. Now, since f prime at t equals psi at t plus c1, we're going to use one of the conditions for the f prime at 0 equals 3. Then we can replace the f prime at t equals 0 equals 3 on the left hand side, and the t will be replaced with the value 0 to obtain the value c1. Psi at 0 is 0. Now we have c1 equals 3. Then we get the first derivative f at t in the form of psi t plus 3. Our goal is to find f at t. So the next round of the antiderivative, we will get the function at t out, which is the final answer. So f at t is the antiderivative of the first prime of the f, which is the antiderivative of sine t plus 3 with respect to t. The antiderivative of the sine function is negative cosine function at t plus the constant. The antiderivative going to be 3 times the independent variable. In this case, the independent variable is t. Or you can think about 3 as 3 multiplied by t to the power 0. So we get 3 times t to the power 1 divided by 1. And after that, we're going to add the constant of integration or the arbitrary constant after the second round of the antiderivative. Now we use the notation C2. So f of t is now in the form of negative cosine t plus 3t plus c2. We're going to find find c2. In this step, we find c1. So next, find c2 using the condition that the f at pi equals 4. As t equals pi, the f at pi is 4. 4 equals negative cosine of pi plus 3 times pi plus c2. And the cosine at pi is negative 1. We should get the value c2 as 4 plus 1, which is 5. 4 minus 1, sorry, going to be 3. And then minus 3 pi. And then equals c2 because negative of negative 1 is positive 1. Subtract 1 both sides, so the left hand side will be 3 minus 3 pi equals c2. As c2 equals 3 minus 3 pi, therefore the solution, which is the function f at t, will be in the form of negative cosine t plus 3 times t plus 3 minus 3 pi.